my talk and the presentation that I'm giving now is covering the Agricultural Catchments Programme's evaluation of the derogation to the Nitrates Directive in Ireland. And I'm going to give a little bit of a background on the derogation and the Nitrates Directive and the Agricultural Catchments Programme, which has been running for the last 12 years. And then I will go through some of our findings of water quality and the impact that the stocking rate has on that. So first of all, the Agricultural Catchments Programme, I'd like to give acknowledgement to the Department of Agriculture, Food and the Marine. They have been funding us, as I've said, for the last 12 years. And we were initially set up with a main focus of the evaluation of the measures implemented under what are called the Good Agricultural Practice Regulations, which is Ireland's statutory instrument that implements the Nitrates Directive. We are a research programme. We also have a very significant part of knowledge transfer. So there are advisors, technicians, technologists, and researchers working with us. And we work in 6 specifically selected catchment areas, initially called mini catchments. They're not large. On average, it'd be around 1,000 hectares. And in all, across the 6 catchments, there are 300 farmers. The catchment boundary follows the watershed, so they're like a saucer. Some of those 300 farmers would be completely within that watershed catchment area. Some would be on the edge of it and would only have a part of their farm in it. The research we carry out is into soil science, hydrology, the weather. We also look at the water quality, naturally, and the ecology. So they're all the biophysical aspects. In addition to that, we have a very significant socioeconomic part of our research, looking at the financial impact of the measures being implemented under the Nitrates Directive and the likelihood of people to implement them. What would influence them to change their mind and change their practice? And the 6 catchments, we do use them as a focus point for knowledge transfer. So we regularly have groups coming out to visit them to try and explain what we have found influences water quality and how agriculture has an impact, be that good or bad. Okay, so these are our 6 catchments, and they weren't picked at random. They were picked to represent very different soil types and different farming systems. I'm going to start with Castle Dockwell in County Wexford. It's a free draining soil type and it's predominantly tillage. 2/3 of that catchment is ploughed every year, and at least half of the catchment is sown with spring barley, most of which goes for malting. Very close by, we have the Ballycanoe catchment, and it's very contrasting in that it has a high clay content soil. When it rains there, the soil gets wet quite quickly, and most of the water flows across the surface. It's predominantly a grassland catchment, although there is about 20% in tillage. Moving up the coast of Dunleer in County Louth, that's a heavier soil type. That would be what I would call winter wheat, potato type countryside. Being a heavier soil type, again, water flows across the surface. We consider it to be phosphorus risky. I'd say it's about 1/3 tillage and 2/3 grassland, and there has been an increase in dairying in that catchment. In County Monaghan, we have Shreenty Carduff, and it's drumlin, picked to represent drumlin soil types. There are small lakes in that catchment and a drinking supply source coming from them. Again, it's very drumlin soil, very mixed soil type, and you'd expect it to be phosphorus risky. In Mayo, we have a karst catchment. It's unusual in that most of the water flowing in that catchment flows below ground. I describe it as being like the burn with 1 or 2 foot of soil across the limestone pavement. Again, all these catchments were picked in intensive agricultural areas. So while we're in the karst area in Craigduff in County Mayo, there still is a significant amount of intensive agriculture taking place. It is good quality, highly productive grassland. Finally, our most intensive catchment is in Timoleague in County Cork. It is predominantly dairying. There are 1 or 2 farms that are non-dairying in it. Typically, there's between 30 and 40 farms in each catchment. And Timoleague, most of the farms would be at a stocking rate in excess of the 170 kilogram of nitrogen stocking rate limit under the Nitrates Directive. These were chosen to represent different farming systems as I've gone through, and the different soil types. Initially our program was established to evaluate the Nitrates Directive, which is a European environmental policy. And it is written into the Nitrates Directive that each member state or each country is required to assess the action program being implemented for that directive. It's not the only environmental policy, but it is focused purely on agriculture, the Nitrates Directive. Other environmental directives of concern and that are having an impact on farming would include the Water Framework Directive. It's kind of all-encompassing. It includes drinking water, coastal water, wastewater treatment, and it includes the Nitrates Directive for agriculture. And there is an objective under the Water Framework Directive that all our water bodies must reach a certain status that's been either good or excellent. That was initially by 2015. We didn't reach that. It runs on a 6-year cycle, and the next date is 2021. Not that far away. Coming down the tracks also, recently we have the Farm to Fork strategy, which sets out targets. This is in the part of the European Green Deal. Sets out targets for a 50% reduction in nutrient loss from agriculture and a 20% reduction in fertilizer use. These are not easy aspirations. They're not written into law yet, but they are written into the Farm to Fork strategy, and they give an idea of where European policy will be coming, or where it will be going in the future. Okay, so coming back to the Nitrates Directive specifically, it was initially drawn up in 1991, and it took us until 1996 for it to be implemented. And as I've said already, it focuses purely on water pollution by nitrates from agriculture. And its objective is to reduce that and prevent any further such pollution. And when we say pollution, it's talking about a discharge of high nitrogen compounds into the aquatic environment that may cause a problem to human health. So there we would be talking about drinking water standards, a harm to aquatic ecosystems. So there we'd be talking about biodiversity and life living in our rivers, lakes, estuaries and in the sea, and the damage to amenities. An example there would be if we had an algae growth at the sea and people couldn't go swimming, or in a lake, if there was a high algae growth and people couldn't use it for recreational activities. Okay. Each member state had an option of applying the Nitrates Directive to their whole country, but I think that more commonly what has been chosen is to implement the directive in what is designated nitrate vulnerable zones. In Ireland, we decided to go the whole country approach, or the whole territory approach. So the rules of the Nitrates Directive are being applied across the whole country. In other parts of Europe, specific nitrate vulnerable zones have stricter regulations to deal with than parts of the country that are not designated as a nitrate vulnerable zone, or NVZ. When these nitrate vulnerable zones were being established, and under the monitoring of the Nitrates Directive, the things that are looked at would be the drinking water standard, which is 50 milligrams of nitrate per litre, or if you're just measuring the nitrogen, it's a figure of 11.3. Those figures are the same thing. One is just measuring nitrogen, the other is measuring nitrate. We're also looking at the state of the ecology, or eutrophic state. Are there algae blooms growing in it? This has been measured under the Water Framework Directive. And the measures that are being implemented to either maintain or achieve good standards are restriction to the application times for fertilizer, having necessary storage capacity, limits for your fertilizer application rate, and one of the few figures that is written into the directive from Europe is that the livestock manure application rate shall not exceed 170 kilograms of organic nitrogen per hectare. Currently, that is equivalent to 2 dairy cows on a hectare. So the Nitrates Directive states that we should not keep more than 2 cows per hectare. In Ireland, we can, and we have always been able to keep closer to 3 cows per hectare, and that is because we have applied for a derogation to this 170 kilogram limit, and it has been approved by the European Commission, and this has to be applied for every 4 years. And the approval and application, it has to be justified. So we have to give reasons for why we think we can exceed the 2 dairy cow stocking rate limit and still achieve the objectives of the Nitrates Directive. Very quickly, I just want to show you some documentation from Europe. This is the last decision, which was given on the 8th of February in 2018, and it granted Ireland's request for a derogation in the Nitrates Directive. In that document, it outlines the previous applications. So the first one was in 2007, again in 2011 and 14, we applied for and received permission to implement the derogation. Okay, and the type of things that they looked for in that, in that application, we outlined that the water quality previously has been generally good, the drinking water standards were good, and the number of livestock over the previous years was outlined, and the growing season, etc. Things like that go towards backing up Ireland's application for a derogation. And you can see there in point 12, the European Commission considers that the amount of manure proposed by Ireland, corresponding to 250 kilograms of nitrogen per hectare, will not prejudice the achievement of the objectives of the Nitrates Directive. So they granted an extension of the decision that was previously given in December 2017. And it will run until the end of December 2021. So next year, we have to go through the process of applying for a derogation again if we wish to continue. And we have to justify it. And the findings, what I'm going to go through now, are the findings from the Catchments Programme that will go towards that application. I do believe it's getting more difficult each time we apply. One of the reasons is the water report coming from the EPA in recent years during the current derogation approval has shown that the trend in river water quality is actually moving in the wrong direction. So the objectives of the Water Framework Directive are going the wrong way. Agriculture is one of numerous sectors in the economy that can influence this, but unfortunately the trend is going in the wrong direction. The Water Framework Directive requires that all our water bodies are either high or good ecological status. And in the latest report, 53% reached this status, which was a decline. More significantly, the excellent water bodies have constantly been fallen from the original reporting period in 1987 to 1990, and they've fallen by close to 14% since that time. It is very significant to note that in freshwater bodies, be they rivers or lakes, phosphorus is the limiting nutrient. A very small amount of phosphorus in freshwater body can give rise to eutrophication, which will have an impact on the ecology. Sediment also will significantly impact on the ecology in freshwater bodies. Nitrogen is not the limiting nutrient, generally speaking, in freshwater bodies. Nitrogen is of concern when you get to the estuary and into the sea. These are the EPA's catchment maps showing the ecological status, and they have them color-coded, bad being red, high water quality being blue, and sort of a blue, green, yellow, orange, red progressively getting worse. And you can see there are parts of the country where the water quality is excellent, or by and large is quite good. For example, in Mayo, West Donegal, Kerry, and parts of southwest Cork. In the east coast, you would see a greater proportion of yellow and orange water bodies. This is a similar graph showing the percentage of the water bodies in each river catchment that are in necessary categories. And we would like those pie charts under the Water Framework Directive. They should be either completely blue, well, preferably completely blue, but blue and green, and they should have no yellow, orange, or red included in them. Nitrate behaves very contrastingly to phosphate. And the nitrate concentration map in the water bodies in Ireland, you can see there's a very distinct region in the country. If you go from Dundalk to Skibbereen in West Cork and look at all the water bodies on the east and south of that line, you'll see that's where nitrate is a problem. And in the west and northwest, nitrate is less of a concern. So what I'm going to go through now is how does nitrate levels found in our water bodies relate to the stocking rate, soil type, how the weather impacts on it, and on the river and estuarine quality. So the EPA have been monitoring for a number of years, and they produced an indicators report in 2018. And this map shows the trend in nitrate levels. And the green dots show a declining trend in nitrate. So in the period for 10 years running up to 2017, in the part of the country where nitrate levels are high, the good news was that the levels were moving in the right direction. Nitrate levels were getting lower. Subsequent to that, a report came out in 2019 covering the period from 2013 to 2018, including 2018. And unfortunately, the trend in nitrate levels had gone in the other direction. There was an increasing trend. And I suppose this gives a mixed message. How come in a period from 2007 to 17, the trend was going in the right direction, and now suddenly it's going in the wrong direction, even though those periods do overlap? So to try and get a better understanding of what is going on with nitrate and the impact of the derogation, we looked at our 6 catchments and we assessed them and looked at the water quality based on and tried to relate that to the number of farms that are in a derogation in those catchments. So you can see our Castledockrell catchment is mostly green, so that it is largely a tillage catchment and the stocking rate is quite low in that catchment. It will be the lowest of our 6 catchments, lowest organic loading. Moving to Timoleague, where most of the catchment is stocked at a stocking rate above 170. Does that mean that the nitrate levels will be higher in Timoleague than in Castledockrell with the higher load? Well, just quickly going through the water quality in the 6 catchments. Above each box there, we can see in the Timoleague catchment, rainfall on average is just over 1,100 millimeters. The stocking rate, average stocking rate level is 168 kilograms of nitrogen per hectare on average across the catchment. It's double what it is in most other catchments. In Ballinrobe in County Mayo, the stocking rate is 83 kilograms of nitrogen per hectare and the rainfall is just under 1.5 meters. In the Drumlin catchment, we have 1 meter rainfall, and again, the stocking rate is very similar at 86 kilograms of nitrogen per hectare. In the Dunleer catchment, which has more tillage, the organic loading is reduced to 65 kilograms of nitrogen per hectare and lower rainfall back to 870 millimeters of rain. And in the 2 Wexford catchments, the average rainfall is just over 1 meter, and the stocking rate in Ballycanoe is 83 kilograms of nitrogen, and in Castledockrell, predominantly tillage, it's under 40 kilograms of nitrogen. The water quality in the Timoleague catchment, the phosphorus level is above the 0.035 limit and the nitrate level is high. We initially wouldn't have expected the phosphate level to be high, but the nitrate level is 0.65. In Mayo, both nitrate and phosphate levels are low, as is the case in Srinty Corduff. In Dunleer, even though the stocking rate is significantly lower, we still have a very high phosphorus reading coming out of that catchment, and the nitrate level is also fairly high at 5.34. The estuarine standard for nitrate would be 2.6. In Ballycanoe, in contrast, the nitrate level is very low at is quite low at 2.6, but the phosphate is a problem there, and we would have expected that because it is a poorly drained surface-fed water body. In Castledockrell, the catchment with the lowest organic loading has the highest nitrate level at 7.06. Being a free draining catchment, groundwater fed, the phosphate level is quite low in the water. So why are these differences coming? And we would attain is the soil and drainage and soil type have a very significant impact on what type of water quality we get. So looking at the whole catchments again and looking at the nitrate, this is the nitrate levels going back to the start of our program across the 6 catchments. And on the graph, they're color coded for each catchment. And the red line is the Timoleague line with 60% of the land in derogation. The black line is the Dunleer catchment. Sorry, I beg your pardon. The black line is Castledockrell catchment with 5% of the land over 170. And it has our highest level. So you can see there is a very significant difference in the nitrate levels being found as a result of the different physical setting, basically as a result of the different soil types. Also, we can see that there was a distinct jump in nitrate levels as a result of the dry summer in 2018. So there was a strong weather signal giving at that time. Following from the dry summer and the drought that we had, the nitrate levels in all 6 catchments jumped to levels that we had never seen before. So to try and get a better understanding of that, I'm going to compare 2 catchments, the low organic load free draining catchment in Castledockrell, which is a slate type bedrock, and the sandstone catchment in Timoleague in West Cork. Both of them are free draining catchments. One predominantly arable and the other predominantly grassland. And you can see in each catchment the dots, the red and the blue dots that are shown there signify where we have boreholes drilled for groundwater sampling. And in each of those dots, we have 3 different levels of groundwater sampling taking place. So for each set of 3 dots, we have 9 different sampling points. And this is just a diagram showing one of those boreholes, so that we have multi-level monitoring wells where we can take a sample close to the surface, just below topsoil, one in the fractured bedrock and one much down deeper in the bedrock with the different groundwater pathways. We're also taking samples from the river close to where these groundwater sample points are taken. So on this slide, you can see at the very top, we can see the fertilizer nitrogen being applied to the 2 catchments. So the nitrogen being applied to the sandstone in terms of kilograms per hectare is significantly more, 3 times more than what has been applied in the tillage catchment. Okay, so there's substantially greater nitrogen applications taking place in Timoleague than in Castledockwell. Initially, if we look at the shallow groundwater well, so just below the topsoil, in both catchments, the nitrate levels are high. That line on the right-hand side shows the the threshold, and the standard of water sometimes is going above that threshold, but it is comparable in both catchments. However, if we go into the deeper weathered bedrock, there is a contrast in the nitrate level when we go a little bit deeper, below 10 meters below ground level. The nitrate level has dropped significantly in the sandstone catchment, while it hasn't changed hugely in the tillage catchment in Castledockwell. The water level in the stream is also significantly lower in the sandstone catchment. So the question really is, why does the slope and resampling, where we have almost 3 times the amount of nitrogen being applied, have half the nitrate level in the stream? It does raise questions, and you would think it doesn't make sense. And the reason is there are a lot of factors that influence the amount of nitrate that end up in the stream, that impact on it from the time it is released or applied to the soil to when it actually ends up in the stream. Nitrate can be applied either out of the back end of the animal, it can come from fertilizer that's been spread, or it can be released from organic matter in the field itself. In any event, nitrate is released. It could be fixed by clover, could be natural deposition, and it falls in the soil. If you have a free draining soil type, you have plenty of air there, but at certain times of the year, the soil can become waterlogged, and there could be heavier soil types that the water flows through before it gets to the stream. And if you get into anaerobic conditions, there are bacteria that will remove nitrogen gas out of the nitrate and release it into the atmosphere, and also a small portion of nitrous oxide. So if you have these anaerobic conditions, or conditions with no air, you will have denitrifying taking place, and it'll lower the amount of nitrate that ends up in the water. As I mentioned, we have a variety of soil types. Everyone knows within a farm, even within a field, you can have a variety of soil types. In the Timoleague catchment, there is a greater capacity to remove nitrogen than there is in the Castledockwell catchment. There is a greater proportion of heavier soils that the water flows through before it ends up in the stream. And this encourages a process which will take the nitrate out of the groundwater along the pathway below the rooting zone before it reaches the stream. And as a result, there are cases, not everywhere, but there are plenty of cases and examples where there is a poor link between the nitrogen leaving the root zone in comparison to what ends up in the stream. Also, across the years, this is work that has come from Owen McAleer, a PhD student that has done the studies within the Catchments Programme, and the previous slides also were from Owen. I have to acknowledge and thank Owen for his assistance with this. But here we're comparing the nitrate levels in his work. He went up to 2014, looking at the stocking rate. And in Timoleague, there was an increasing stocking rate. In Castledockwell, the organic loading remained pretty constant. So 60% of the land was in derogation, and that is increasing in Timoleague. In Castledockwell, it's steady, it's the same. The nitrate levels in the water body up to 2016, by and large, remained unchanged. If anything, they were falling in Timoleague. And in Castledockwell, there was a significant upward trend in nitrate levels, even though there was no change in the nitrogen loading. And Per Eric Melander and Owen have looked at this and compared it, and the increasing trend in nitrate levels in Castledockwell is very much tied in with changes in our weather pattern since that over that period in time. So to try and look at a single soil type we have broken our catchments down into smaller sub-catchments that would have comparable soil types among them. And David Ryan would have explained last week in his presentation that in addition to our Teagasc, where we take a sample every 10 minutes, we also call out and take a grab sample once every 4 weeks or every month along the main tributary, the main channel, which is M1, M2, M3, M4, M5, and M6 are where we take 6 grab samples along the main channel. And again, in our tributaries, it's either T1 and T2, and T2A and T2B. So they're where we take a grab sample every 4 weeks. And we can compare the water quality from each of those sub-catchment areas and compare the stocking rate in those sub-catchments to see, is there a direct relationship between stocking rate and water quality, even where the soil type is quite similar. And looking at the sub-catchment approach, there's a graph of the nitrate levels in Timoleague from going back to the start of the programme, and you can see there's an annual up and down cycle of nitrates. Every autumn in the recharge period, the nitrate levels tend to increase. And in the bottom graph, we're comparing the main channel sub-catchment M5 with the tributary 1A. And you can see the percent of derogation in tributary 1A, there's a higher stocking rate. 85% of that catchment is in derogation versus just under half in the main channel M5. The nitrate level has increased as we've gone into the higher stocking rate from 4.27 to 5.81. You can see in that catchment there was an increase in nitrate level as a result of the increase in stocking rate. In another catchment where we carried out a very similar analysis, we looked in Ballycanoe, which is our heavy soil type. You can see the nitrate levels also fluctuate annually, but the base level is much lower in comparison to the previous slide, where the nitrate levels were hovering either side of 5 milligrams of nitrate per litre, nitrogen per litre. In Ballycanoe, we're either side of maybe 2.5, half the levels of nitrate. And we're comparing the outlet figure of 2.6 on average for the whole catchment with different sub-catchment areas. So you can see as we go from sub-catchment M1 in comparison with tributary 2, the percentage of land in derogation actually reduced from half of it being in the derogation to a third, and yet the nitrate level actually increased. So there was an inverse relationship to the stocking rate. And you can see in the upper reaches of the catchment, the nitrate levels were also slightly higher than M1, but there was no land in the derogation, or very little. So in summary, we can say that nitrate, and this is nothing new, but nitrate is a complex element, and the pathways and the loss of nitrate and how much nitrate ends up in our water body is not a simple thing to analyze. And it's not as simple to say that an increase in stocking rate will directly give an increase in nitrate loss. It will in some cases, but there are other factors that influence it, and they may well have a greater influence and override the impact of the stocking rate. Nutrient source is important, but equally soil type, geology, and the weather all have a significant influence on the amount of nitrate that ends up in our water bodies, and they all interact with each other. And if we are to put in place actions to try and minimize nitrate losses, we must be aware of all these factors. And when they are designed and put in place, it is equally very important to keep in mind that farmers need to change their practice. So social and economic factors that influence the uptake of these mitigation actions are very important. And Michelle McCormack from the Catchments Programme has given a talk on that in the presentation after this, and you can also catch up on it on the YouTube channel looking at the Signpost webinars. Thank you very much.